All right, here, you got it.
Okay, how do I talk to like this?
Talk.
What's up, guys? Welcome back to the channel. Today we're gonna be going over Chapter 12 notes.
No, this
Let's
is
Chapter 13 notes.
Let's go.
Okay, handing it over to Heller.
Great, thank you so much. Thank you so much.
Intro.
Yeah, that was really nice. That was really nice. Chapter 13 is, as I put on here, all of Unit 7. So we're now like kind of doing a unit at a time. So that means we only have 2 units left after this.
Are you serious?
I know. It's wild. It's wild.
How many more chapters?
Several. Several. Remember, you owe me a chapter test.
Like how many is several approximately?
I think we go up to chapter 18.
That's like 5.
So you owe me chapter 12. The next day I see you.
Oh, you it.
Well, yeah. I mean, I guess you don't owe me. You don't have to do it. I guess you don't have to do anything, technically.
Free will. We do what we want. Don't remind me.
Guys, I don't know if you saw social media, but Science Club was pretty lit.
Yeah, my mom will do it. My mom will do Science Club. Why aren't you in Science Club?
Yeah, exactly.
I was like, what? Wait, no one lit about it.
We did Elephant's toothpaste, and it got like all crazy. Actually, worked. It was. Okay, so this is the thing we have been alluding to for a while, which is equilibrium. So we have reached it, we have made it. So this is the foundation of the rest of AP Chem. Have you guys seen Foundation on Apple TV? The show? That's interesting. Kind of like a space time travel show. It's right up my algorithm.
My algorithm.
Yeah. I love Interstellar. If you like Interstellar, you probably like Foundation. Okay. So, many chemical reactions are reversible. Many chemical reactions are reversible. In terms of chemistry, you may see on the AP test, examples include a solid that could dissolve, and then if it undissolves, what is that called? We don't call it undissolves. What does salt do when you like evaporate the water? Recrystallizing. Recrystallizing. Electrons being lost and gained, which is an example of redox. Remember Big Fat Red Cat? Yes? Big Fat Red Cat, oil rig. Yes? Okay. Oh, sorry, Big Fat Red Cat, we haven't done that yet. We did oil rig or Leo the Lion Goes Grr. We'll save the Big Fat Red Cat for later. Okay. And hydrogen ions, H plus ions, being exchanged in acid-base reactions. So those are some examples of what we've seen so far. Most of those reactions come with some kind of observable event. Some kind of observable event. Examples, color change, bubbles. That will allow you to see the process is reversible. A dynamic equilibrium. That just sounds so fancy, doesn't it?
No.
A dynamic equilibrium. I am hungry too. I should have got myself a sweet treat. Exists when the rate of the what?
You're going to sweet.
Well, that's what Ella said.
I did.
When the rate of the forward reaction is equal to the rate of the backward. Of the backward reaction. At the beginning. At the beginning of a reversible reaction, reactant concentrations are high. Right? We've seen that with our rate law chapter we just finished. Remember how they were going down, they started here and they ended up going down? Yes. And as a result, the forward reaction is also
High.
yes, so smart. High. Also high. And it's the opposite for products. It's the opposite for products. So as the reaction proceeds, the reactant concentrations keep falling and the forward rate will decrease. Once again, the same is true for products. So take a look at this chart. So here we would have reactants, here we'd have products. I start out with reactants and then they end up going to basically constant. I start with no products and they end up going to constant. So we're going to do a lab like this that proves this to you. It's really weird.
Weird.
Yeah. It's not what you would expect.
Like what? That we did
What?
one time. I bet someone weird that one weird potato sludge thing.
No, we're not doing a potato sludge lab, but
Oh
it's really weird. So, after equilibrium is reached, a sudden introduction, I'm just going to write intro, I'm not going to write the whole thing out, in reactants. So if I added more reactants, that would result in a dramatic increase in the what? In which way? Forward or backwards rate? If I'm adding more reactants, that's going to make more products, right? That would make it a sudden increase in the...
Wait, then is backwards products?
Yes. Then a new equilibrium would eventually be reached. Flip the page. You're crushing it. You're crushing it.
Context clues.
What?
It's like context clues.
Yes, the context clues are everywhere. Henry, are you okay?
Yeah.
Okay. Just making sure. Why are you so tired after snow day?
Exactly.
Guys,
I pulled a Nathan yesterday. My car did a 180, and it was so scary. Oh yeah.
you mean if you pulled a Nathan?
Oh, that was Nathan.
Yeah.
I pulled a Nathan, and it was so scary.
I got about 16. I almost hit someone in Starbucks.
Guys, whenever we have a snow day, when I predict a snow day, I get so amped that I'm right, I can't go back to sleep. So,
Serious?
I had one person text me at 5:40 and be like, "You were wrong," and then 10 minutes later they're like, "Oh, you're right."
Who was it?
I'm not gonna say who it was.
He's strong.
Although Mr. Burdine was hating on me.
He was. I heard him. He
Yeah, Mr. Knight.
What? Yeah, and they are all wrong. That's how it works.
They hate it because they hate you because they ain't you.
Wait, what, the email, right?
What email? Oh my gosh.
It did, yeah, it said what you said.
Listen,
My mom read it to me.
when I saw this, I was like, I am a genius. Hold on.
My mom came out.
I'm also humble.
And I was like, you need to read this.
Good morning. Due to the current... Shh. Guys, I'm being really humble right now. Let me be humble. Good morning. Due to the current road conditions and the pending forecast, Worcester will be closed Thursday, January 16th.
Did you say due to the incoming, like the...
Yeah, like what was going to still to come.
Yeah.
Yeah.
What do you think it's gonna say on Monday, Tuesday?
I think he's going to call it Monday night for Tuesday so we can stay up late and watch the national championship game.
Yes. I think he's gonna do it on purpose.
And I bet he'll say something like, "Go Buckeyes."
Yeah.
I don't know.
Oh, he died.
How accurate you are?
No, but it's like 90% or
That way
higher.
you can get your like actual.
I should keep
And you
it.
could like keep it going for like 20 years.
I don't know. My wife actually asked me how many days she thinks I've predicted over like the 16 years, and I'm like, I don't know,
Yeah, why don't you like a count? Like
at least 50. I mean, you average 2-3 a year, so you just gotta be careful and not let your heart speak. You have to let your head speak. All right? Because like your heart always wants a snow day, but you got to look at the science and the models. All right? It's easy to say like it's gonna be a snow day, but like just because you want one.
We talked in my Golden Goose class first grade when I was young. There was a 10-minute conversation about you predicting stuff.
Really? What was it about?
About how what's his name? Yeah, I don't know.
Okay.
But no. He kept like dogging on you and like
Why?
saying like, well, Mr. Miller's wrong like all the time. I don't
No,
know.
I'm not.
And then some like freshman in the class was like, he just predicted the snow that happened yesterday, and he said what the email was gonna say. And Mrs. Young was just like, yeah, Mr. Miller has all this like stuff that he looks at, all these things, and I'm like, and I didn't even say anything, I just listened.
Thank you. I appreciate. I know you would have stood up for me if you
I would.
felt like you had to.
No, I wouldn't.
I know you guys always protect my honor. That means a lot.
So maybe will like call me just some random day and just, like we're gonna have a snow day tomorrow. It's like,
I'm like,
And it's like May when he does this. Okay.
every single day, he's like we're gonna have a snow day tomorrow.
Yeah.
He called like 3 snow days in December.
Every day that's
we have.
All right, let's keep going.
We did?
No.
In December?
Yeah, we need to lock in.
No.
Well, then I might be like one.
When equilibrium is reached, it may appear on a macroscopic scale, which means what?
Large.
Big scale. all right, that the reaction has stopped. It may look like it has stopped. Closer inspection on the microscopic scale. Yes, so good. Confirms, in fact, it's still going. At equilibrium, both products and reactants are present in the mixture. We're going to get to see that in a lab. Well, it just depends when we get back. We still need to finish a lab that I was going to do before that. If the products and reactants have observable differences, like color, because it could be color, the reaction mixture should be a combo of the two. So here we go. Here's a reaction. It's red and it's blue. If it is at equilibrium, what colors? Yeah, it's going to be purple.
Yes.
Now, it's going to be purple. If I add more red in, right, how's it going to look?
Red is purple.
It's going to look more red. If I add more blue, it's going to look more
Indigo.
bluish. Yes. Look at that. What if I remove red? It's going to look more blue, right? If I remove blue, it's going to look more
Red.
Okay, you guys are getting it. Okay, good. I know.
I'm glad we're all picking up.
The good thing is that equilibrium, this just basic stuff is not that bad. Like I said, these next two chapters are kind of easy.
Don't do the color wheel in my city art class. You say we're easy.
You also said last chapter was easy too, and last chapter was kind of.
Holy crap, that chapter cooked me.
No, that was more conceptual.
We haven't on the test yet, so
Are you talking about the kinetics, the rate laws?
The one that we
The
get.
half-lives?
I'm cooked.
The half-life is.
Yeah.
It's just so many formulas.
You said Vesper was easy and then I got.
But you have all the formulas. Also, make sure you have a calculator or Desmos whenever that next day is.
Look at this.
Nice. Okay.
Shakalaka.
Depending on the amounts of reactants and products that will change the color, and you could estimate, the relative numbers of reactants or products in the mixture. I'm going to a place tonight with friends. I think it's called Twizzle Sticks.
I'm sorry. That is my
Hold on.
I'm sorry.
That does not sound right. Let me check it.
I mean, that's cool.
Fizzle Sticks.
Okay, that's literally
That's so much better.
Has anybody been to Fizzle Sticks? It's in Maslin.
NBC.
You are literally
Let's
going to
see if
have
we
those
can
that
get
are
a
Listen, I'm just saying they've got this burger called the Gargantuan,
This is literally in
and it's a grilled cheese, a double cheeseburger, and then a grilled cheese.
so I would throw it.
How do you better get that?
How do you get fitted?
I kind of want to try it just to see. Yeah. What? I don't know.
Yeah, do you get a plaque?
I don't know. You can also they have like 9 different types of fries,
Oh, I love.
and you can get a flight of fries, like 3 different kinds. Yeah.
Where is this?
It's in Maslin apparently.
I'm going.
I'll let you know.
Yeah, let's see if we can get
I will take pictures
of the.
of all the food that we eat tonight
Justice for Star.
on Google Classroom. I can just show you too.
We don't make
Say that they're online.
No, I've created enough problems with Remind already today, okay?
You do a review. Thursday, you gotta post
Do a review on your YouTube.
Yeah.
Be like, hey guys, welcome back. This is a
And
review.
it'll premiere it and I'll be like the music with the bum, 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 bum. What's up, guys?
Oh yeah, it's gonna be you guys.
Wasn't that for notes? There was like a counter.
Me and him.
Apparently when you do a live review, it,
What's up, guys?
yeah. What's up guys? We're starting chapter 12. We're starting chapter 13. All right. So we can estimate the amounts of reactants and products. Usually the thing is it's my fault. Yes. Should I? All right, guys.
Yeah, we've done like over 3 sentences.
Look at this photo. This was somebody's setup during CP Chem.
Wait, I know who it is.
Okay, then I can't show
No,
it.
no, 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 no. I know who it is, but it's show it.
It's just funny.
I'm not gonna say who. I'm not gonna.
It's just funny.
CP Chem.
General chemistry. That's pretty good.
I know exactly who it is.
Look, they put the clamp on the Bunsen burner. I don't think they're going to be able to heat it very well.
No, you need a second Bunsen burner.
Oh, a second Bunsen burner on top of that. I don't even know whose it is. I just know the picture.
Yeah.
It's just a funny picture.
Bro, what?
That's something good.
Lips are sealed with fully perhaps better.
That's funny.
That's getting real warm.
That's funny. Guys, imagine trying to unclamp that, like, because the top of the Bunsen burner's hot. All right. So, here we go. Here we go. And now, for another K.
I literally got told about this last week.
You did? And not only the K, the most important K of chemistry. It is the equilibrium constant.
I already started before.
Why is there so
So once, I told you, it's just K's all over the place. All right?
Okay.
Is that mic gonna pick that up?
I hope it did not pick that up. We do not approve anything that's said in the audience, and that person did not mean to say that.
I'm gonna go back and watch that. That's so.
Wow.
Wait, how much time?
The face.
How far are we into the?
I don't know.
5 minutes, like 20 minutes?
The real.
I cannot believe that, Lucy. I understand what you were doing, but wow. All right. It's okay. We know that was not purposeful. I know. You were just saying K, lots of Ks. All right. What'd you say, Joe? What'd you say, Joe? Oh, we're not going to finish it. It's okay.
Here we go, guys. I'm so
Okay, but you're okay. We're okay. We know your heart.
Brady's not okay.
All right. What Lucy was trying to say was lots of K's.
No, I was just being like, hey, but it was also.
Like AAA, that would have been fine. Or BBB, it just happened to be. All right, wow.
Everyone shut up about it. I know what I did. It's fine.
She knows, all right? She's embarrassed, she knows.
I don't call her make
Apology video. Apology video. Give it tears.
Hey guys, welcome back.
The equilibrium,
I gotta make a confession.
the equilibrium constant, sometimes seen as Kc, because it's K constant, is given at a constant temperature. That's really important. So this has to be at a constant temperature. Consider the equilibrium below where A, B, C, and D are the stoichiometric coefficients of substances A, B, C, and D respectively. So here would be an equation. Little a, big A, AQ, states are going to matter for this, plus little b, big B, AQ, big B, the coffee place, plus little c, big C, yield, sorry, is an equilibrium with, plus little d, big D, AQ. So we have AA, BB, CC, DD. What?
Why does the little letter?
No, not AB.
The little letter? Because that's a coefficient. I'm going to show you why.
Oh.
So if I was going to write, you can actually write an equilibrium expression for these. All right? If I was going to write an equilibrium expression, here's where I would look. First of all, it's always products over reactants. So make a little note over here on the side. It's always products over reactants. I might be getting in my head ahead myself, but I just want to write it. It's always products over reactants. So the equilibrium expression for this would be concentration of big C to the little c. That's really kind of hard to see. Looks like the same thing. Times the concentration of capital D to the lowercase d. Do you guys see what we're doing here? We're raising it to its coefficients. Over the concentration of capital A to the little a times the concentration of capital B to the little b. So it's products raised to their coefficients divided by the multiplicand of your, oh, I said multiplicand. Man, fancy. Of the reactants to their coefficients. Multiplicand, I think it is.
No, I'm
Is that a word, Henry?
it sounds like
Okay.
I've never heard of it.
All right.
Yeah.
I don't know.
No, honestly.
All right. So this is where concentration represents the equilibrium concentrations, aka the product. I'm just going to say this. I already said this. The product of the equilibrium concentrations of products raised to their stoic powers divided by the product
Are we going to be doing stoic in this?
of the equilibrium concentrations, yes, of reactants, always stoic, raised to their stoic powers. Kc, you're going to like this, has no units. So while the K in our chapter test you're taking the next day I see you, the units get weird. These have none, but why? Think about it. They're going to cancel out, right? They're going to cancel out. A couple side notes. First of all, Kc expressions. Kc expressions don't include pure solids. So those would be signified by an S in parentheses. Or pure liquids, which would be signified by a lowercase l in parentheses. So solids and liquids are not included. Why? They don't affect the concentration, right? If I put a piece of solid aluminum in something, as long as it's not reactive, is it going to do anything? No. Water isn't going to do anything. Side note number 2. Using Kc at equilibrium gives you K. It's about to get crazy. But at other points, that being anything but equilibrium, usually the beginning, so put beginning in parentheses, you get Q. So instead of K, you get Q. What the frick is Q? Great question. It is the reaction quotient. Quotient. And we're going to compare Q to K to figure out what happens in the reaction. So it's the same expression, just at a different point. I'll show you in a second what we're going to do with that. So example, decomposition of hydrogen peroxide, write the expression for Kc. First thing I have to do is write my what? Go to write a K, balance equation, right? So I have H2O2, just be careful what you say, Lucy, okay? Is an equilibrium with, that breaks down into H2O, which is, we're going to say aqueous for this one, plus O2, which is also aqueous. So it's possible to have aqueous, we're just, I know, but we're going to say it for this one as aqueous, just for fun.
Is that an
AQ.
AQ? That's not two A's.
What? That's AQ, AQ. AQ, AQ. Is this balanced? No. 2 here, 2 there, that's balanced. So if I was going to write a K expression for this, I would say Kc equals concentration of H2O, what? Squared, times the concentration of O2, now you're seeing it instead of letters, over the concentration of H2O2 squared. It's just the number from the balanced equation. That's the same thing as what I was trying to show you here, right? The coefficient becomes the power. The coefficient becomes the power. Things people make mistakes on. Mistake number 1, they do reactants over products, okay? Mistake number 2, they forget to make that the power. That's so sad when you're grading the AP test and they flip reactants over products. Because I can't count that. We can count a transcription error, but we can't count that as a transcription error. All right? What's a transcription error? Great question. So let's say you just wrote this as like, instead of like H2O, you wrote like HO. All right? Like you just left out something, and we can tell it's a transcription error. But if you flip it, that's not a transcription error. No. You can actually get 1 transcription error for free.
I have one on my list.
From the whole test or
What?
per question?
it would be per FRQ. But like, you're probably not going to have more than one. Yeah. Flip it. Flip it. Okay. So here we go. Number one, consider
Stop laughing. It's over.
the following. Here, this is why you don't want to miss AP Chem. You never know what's going to happen.
And then Mr. Hall makes you feel bad, so.
I was not trying to make. I thought I was very gracious.
You made yourself a Jesus.
I thought I was super gracious.
He's giving you a warning. Yeah, you could have gone.
I was mostly kidding. All right, we have to be careful what we kid about. Okay, I'm just mostly
You
kidding.
should have been more careful when you kid about.
She's taking that personally.
What did I say?
Oh.
Consider the following reaction. Consider the following reaction where butanoic acid, that's a fun one, reacts with ethanol to produce the ester ethyl butanoate and H2O. In 3 separate experiments, all at the same temperature, equilibrium was achieved, and then following data was collected. In each experiment, calculate the equilibrium constant and comment on the values. So here is my equation. Here's my balanced equation. So notice that I have gases here. Gases work too. You can do this with a gas. We're going to talk about it more specifically in a second. So in order to calculate K, the first thing I have to write out is my what? KC. I already have the balanced equation. So I'm going to write out my KC. So KC equals concentration of this times this, right? So C3H7CO2. This, why did I pick such a long thing? C2H5 times concentration of H2O over concentration of C3H7CO2H times the concentration of C2H5OH. Yes? So if I wanted to solve for Kc, I just sub in numbers. Kc equals, so let's do experiment number 1, right? Experiment number 1. I would have ethyl butanoate, that's this big thing. Or no, hold on. C3H7O2H5, that is, yeah, ethyl butanoate. So that's 20, right? So I have 20 moles times H2O, which is 20 moles. You guys good with where I'm getting these numbers? I'm just going from experiment 1. Over 10 moles times 10 moles. 10 times 10, right? 10 moles times 10 moles. 20 times 20 is 400. 10 times 10 is, bless you, 100. 400 divided by 100 is 4. So Kc equals 4.
Just 4. It feels weird to have this number.
It's just 4.
Mr. Heller, am I going to show you something on my phone of it?
Okay. It's just 4. Now, I could do this for other ones, but guess what? What's 40 times 10? What's 40 times 10? What is 40 times 10?
400.
What's 20 times 5? 400 divided by 100 is? 10 times 12 is? 120. 1 times 30 is? 120 divided by 30 is? They're all the same. Why? What's constant? Why? Thank you, Henry. Because at constant temperature. If the temperature doesn't change, your K should stay the same. Coolio? Yes? Ooh, you're not going to like this next part. On a Friday, after like a weird week, we're going to do it. Sometimes we know the initial amounts, and then equilibrium is reestablished. That's when we use ice tables. Yes. Yes, our Ice Baby Dance was all leading to this. All leading to this. That's actually why we picked that song. No, it's not. All right. But what if it was? That'd be wild.
That would be like mastermind.
That'd be
Yes.
like even more than JK.
That would be like Ocean's 11 level. Those are such good movies.
That's right there.
You never seen Ocean's 11?
Is that one movie or is that the 11th movie of it?
That's the first movie.
Isn't it like the gambling dude? Like
It's where they try to rob a casino. I don't want to give it away. It's
Just give it away.
Never heard of it.
who has never seen Ocean's 11? Raise your hand.
I've never heard of it.
Who has seen Ocean's 11?
What is this?
I've never even heard of it.
Ocean's 11 is like Brad Pitt, George Clooney.
Ocean's 8, the one with like all the girls.
No. Oh, well, yeah, that's the newer version of it. And they're like trying to like rob a casino. I can't give it away. Like, it's so good.
they're all like mic'd up in the
Is
casino.
anyone in here gonna watch it? Does anyone not watch it?
Okay, so what happens is they do this whole thing, and then like it looks like they get caught at the end, but it's all like a farce, like to the viewer, and then like it's this crazy, like, what would you call it? Paradox of what actually happened. Yeah. So it looks like they get caught. They get caught, and they actually rob the casino. It's amazing.
Okay, now I'll watch it.
It's so good.
I'm so lost.
What's it
It's
on?
a-
Watch it.
I don't know. Probably Amazon Prime.
Wait, yeah, at the end of the year.
Ocean's 11.
I think it's on.
After the AP test, we should watch it.
Yes.
We'll bring it up.
Write that down.
Is it rated PG-13 or better?
Yes.
If it's
Yes. You just said that. You don't even know. Henry's like, yes. He's so confident.
He knows the rating.
It has to.
you can show higher rated if you do a form.
Oh yeah, parents have to sign it.
Yeah, well, I'm not doing that.
That's worth it. Yeah, well, I'll just, yeah, that's fine.
What is Ocean's 11 rating?
Well, it's gonna be hard.
PG-13.
Yeah. We're good. We're good.
So long.
Calculations. Here we go. So, using the reaction in the KC calculated in question 1. So here's our K, right? Calculate the number of moles of each substance present at equilibrium. So, when I'm talking about present at equilibrium, this is where 1 mole of butanoic acid and 2 moles of ethanol are mixed at the same temperature. How do you do this? In any equilibrium, the reaction is incomplete. Why is there so much happening outside my room right now? Meaning we can't predict.
And make it like a slam thing, no.
Like a what?
No, don't slam it.
Like, teacher,
Oh, that
just
was
like
very-
slam it when you be outside.
You could have done it a little more forceful than that, but no, it's fine. It's
Like,
fine.
you have to like make it.
No, don't. It's good. No, don't do it.
There we go.
Okay. Meaning we can't predict the number of moles of products based purely on the stoic like we can in the reactions that go to completion. Because most reactions don't go to completion. We've said that. In order to account for this, we must use an ICE table. Make ICE in all caps. It does. It does stand for something. So, first thing we need to do is we need to rewrite our equation from the top. So from the top, I have C3H7CO2H, which is a gas, plus C2H5OH, which is a gas, is in equilibrium with C3H7CO2C2H5, which is a gas, plus water. Plus water. So, here we go. Our first I. Any guess for what the first I stands for? The first I stands for initial. It's what I start out with. So, it told me I'm starting out with 1 mole of butanoic acid, so I have 1 mole of this. And I'm starting out with 2 moles of ethanol. 2 moles of this. Am I going to start out with any reactants here? Does it say I have any to start? No. So I've got 0 and 0 here. C stands for change. C stands for change. So I am going to, am I going to lose product and gain reactant, or am I going to gain product and lose reactant? how is this going to change? I'm going to lose product, right? Do I know how much product I'm going to lose?
Is it just the amount of mold that you have?
I don't know how much of this I'm going to lose, right? Because it's unknown. We don't know where it's going to go. So would you agree that I'm going to be minus x? Yes. Here is going to be minus x. What about on this side? Plus x and plus x. Now, unless one of these coefficients was a 2. If this was a 2, it would have been plus 2x. Okay? Would have been plus 2x.
Is that equilibrium is one side products and one side reactants, or are they both just both?
So this is products, this is reactants. I'm not at equilibrium. I'm trying to figure out what is the concentration at equilibrium.
Okay, I thought you said products for the first side, that it was confused a little bit.
Reactants, products.
Right, okay.
So guess what E stands for? Equilibrium, yes. So at equilibrium, for me, it's 1 minus x, it's 2 minus x, it's x, and x.
Wait, what is
I'm just going to write out what I have. I have a 1 minus
that?
x.
Like the mold.
I've got 2 minus x. I've got rid of the moles. I have x and x. So now I have to write my k expression, which I've already done, right? My k expression is here. Yes? Have I solved for k? It's 4. So I'm going to say 4 equals, what are my two products? So that would be x squared. Are you guys okay with that? Right? Over 1 minus x times 2 minus x. Oh, snap. We're going to have to FOIL this? What?
Yeah, where's Mr. Drown?
So 4 equals x squared over x squared minus 3x plus what? Plus 2. So I could multiply across, right? So that means that 4x squared minus 12x plus 8 equals what? Equals x squared. Right? Yes?
Oh.
So minus the x squared.
So minus the x squared,
Equal to 0 and then factor.
3x squared minus 12x plus 8 equals 0. Will Desmos do this for you, or are you going to have to do it in your head?
Smiles at us.
What?
Smile.
Okay. So what do you get? You can't put that into Desmos and it'll give you two numbers? Try it. Look at the graph.
Smile.
Or smile. Try it. What'd you say?
No.
Quadratic formula.
If you're Henry, you can do that.
What?
Miss Burkett.
It'll be good.
So what happens when you put it into Desmos? You're going to get two answers, right? A positive and a negative. Is a negative going to make sense? No. Are you doing it, Joe? Thanks, Joe.
Let's go, Jay.
Sure. And what are your 2 points? It's 0.845. Yes. So x equals 0.845. X equals 0.845. Did it give you a second point? But it would be the first one. It'd be the first one. And let me tell you, you're not going to do quadratic formula on the test. On the AP test.
On the AP test or on our test?
Either test.
Is it gonna give you like the graph?
And that's why it's up there. All right, it's for this. What'd you say, Ella?
Is on the AP test, is it gonna give you each normal decimals, or is it gonna be the graph for decimals?
I don't know.
I hope it's graph.
There's a lot of questions about the AP test on my AP Chemistry Facebook group right now. People have no idea what's going on with it. So, have you guys used
Can I join the group?
Have you guys no? Have you guys ever used Blue Book?
Yeah.
So I haven't even used Blue Book yet, but that's so we're gonna take your test on. So yeah, but I don't know how that's gonna work because like you guys need to like write stuff out. I don't know. Flip the page. Flip the page.
Get the links in.
Let's try to finish this one and then call it a day. I think we can do it. I think we can do it.
Go and become an AP chemistry teacher so I can go. There you go.
Another Esther, just like pretend.
So you guys studied at the Ohio
Welcome
State
back, guys.
University.
Today I'm joining this.
Winner who's not going to be let into that group. Just saying. Another ester, ethyl ethanoate, can be formed by the reaction of ethene.
It's great, he's laughing.
C2H4 with ethanoic acid in an inert solvent, according to the equation, C2H4 plus CH3OH gives me this. In one experiment, I have 0.5 moles, right? 0.5 moles of ethene. And let's just write down what this is so we see this is, can we put E for ethene?
Yeah.
Let's put EA here for ethanoic acid, EA sports. It's indicated. And EE for ethanoic acid. I just feel nervous whenever I say two letters in a row right now, because I don't want to say EEE, okay? No, I don't think it is, but. All right. So, you are. That could go on the, that's the only thing we can put on the t-shirt is Lucy equals canceled.
No, with the red.
But cancel spelled.
No, but you have to do like the
No.
arrows. That's not funny. Oh my god!
All right. In one experiment, 0.5 moles of ethene were allowed to react with 0.250 moles of ethanoic acid in the total volume of each mixture is made up of 500 milliliters with an inert solvent. This 500 milliliters is important because notice that they're giving me moles and liters. So guess what I'm going to have to solve these into? Molarity. When an equilibrium has been established, the mixture was found to contain 0.220 moles of ester. Calculate the molar concentration of all three substances present at equilibrium, hence the value of Kc. Here we go. Let's write our balance equation. We have C2H4 plus CH3COOH is in equilibrium with CH3CO2C2H5. So, it's a lot. Initial, they told me I have 0.5 moles of ethene, right? Yes? So what is 0.5 divided by 0.5? 1 molar. Does that make sense where I got 1 molar from? Yes? That's why, just me handing these out, you got to watch the process. It wouldn't make sense for me just to hand this to you. I have CH3COH, so that is ethanoic acid. I've got 0.250 of that. So 0.25 divided by 0.5 is what? 0.25 divided by 500 is going to give you, wait a second, 5 moles ethanoic acid.
Because you changed it to 0.5?
Yeah, because it'd be to liters, right? 0.25 divided by 0.5 would be 0.5. 0.5 molar. Do I have any product to start out? 0. Change. Minus x, plus x. Equilibrium, I have 1 minus x, I have 0.5 minus x, and I have x. Yes? Let's write out our K expression now. Kc, wow, equals concentration of CH3CO2 C2H5 over concentration of C2H4 times the concentration of CH3 COOH, subbing what we got. It is a lot. So, Kc, do they tell us anything? Do they tell us anything? Oh, the mixture, when equilibrium has been established, the mixture was found to have 0.220 moles of the ester, right? So that means that X, right, is equal to 0.220 moles, right? Divided by how many liters? Divided by 0.5 liters, yes? So what does X equal? I'll just tell you, it's 0.44. 0.44 molar. Now, if I have this X, can I figure out these two? 0.5 minus 0.44 is what? 0.06. 1 divided by 0.44 is 0.56 molar. Now, can I solve for K? I've got everything I need, right? Yes? So that's going to be 0.44 molar products over reactants divided by 0.56 molar times 0.06 molar. That's 0.44. That's really bad handwriting. Divided by 0.56 times 0.06. Any calculators out there? We're running out of time. I'll just give it to you. Kc equals 13.1. Our test is the next day. Next day is our test. We will continue this later. This is not that bad.